Hello students, so now we will discuss your group 15 elements. In the previous class we have covered the general trend in properties along with how particularly nitrogen differs from the properties of rest of elements, how it differs, and now few compounds we have to discuss, that is dinitrogen. Okay, right now we will go through the topic dinitrogen. Okay, so that is dinitrogen. It is designated as N2. Okay, so you know nitrogen belongs from second period. Okay, nitrogen belongs from second period of long form periodic table, and it is the third element. It is the third element of P block. Okay, so it is the third element of P block, you know, nitrogen. So this is your group number 13, this is group number 14, and this is your group 15. Okay, here that is nitrogen, and suppose this is your group 16. So this one is nitrogen, so before that is carbon, and here oxygen, and this is phosphorus. Okay, so the surrounding elements or neighboring elements are carbon, phosphorus, and oxygen. Okay, now its elemental form, you know, it exists as I have provided the detailed explanation why it exists in diatomic molecule. It exists as diatomic molecule, that is N2, or this is also known as your dinitrogen N2, or this is known as your dinitrogen. Okay, so the elemental form of nitrogen, that is N2, it exists in the form of N2. Okay, a diatomic molecule. Clear? Okay, so now straightforward we have to discuss the preparation of dinitrogen. Okay, as I have told you, in the group elements you have to remember the chemical reactions. You practice it several times and try your best level to remember this preparation and chemical properties. Okay, no more tough topic is behind them. Okay, so that is next is preparation of dinitrogen. Okay, preparation of dinitrogen. So in preparation, first one, that is by heating ammonium nitrite. By heating, first method, by heating ammonium nitrite. By heating ammonium nitrite. Okay, so this ammonium nitrite is formed, first one, that is NaNO2 sodium nitrate plus NH4Cl. Okay, little bit of heating is required. You are getting over here NaCl plus NH4NO2. This is called ammonium nitrite. Okay, ammonium nitrite. ठीक, next this ammonium nitrite NH4NO2 ammonium nitrite, upon heating it will give you N2 plus H2. So you multiply 2 in order to balance the equation, and so this is one method of preparation. Second, you can heat your ammonium dichromate. Okay, so ammonium dichromate, that is NH4 whole 2 Cr2O7. This is ammonium dichromate. Ammonium dichromate. Ammonium dichromate on subjection of a heat. Okay, when subjected to heating, then dinitrogen is obtained plus Cr2O3 plus H2O. Okay, if you balance this equation, so that will be, so here that will be 4H2O. Okay, 4H2O and Cr2, 7 oxygen, 7. So this is the required equation. Okay, so now this dinitrogen can also obtained when ammonia gas is passed over, when ammonia gas is passed over your Cu, cuprous oxide. Okay, so the reaction can be written as NH3 plus CuO, then that will be pure copper is obtained over here, plus N2 plus H2O. Okay, so if you balance this equation, 2, 3 and this will be 3. Okay, 6 hydrogens, and here also 3, 6 hydrogens. Okay, 3 oxygen. So the equation is balanced. Okay, so next, these are the important preparations of your dinitrogen. Again, such dinitrogen can also obtained by heating your nitrides or azides. Okay, so if another method of preparation is there, if you heat your that is called nitrides by heating nitrides. Okay, so nitrides, suppose I take sodium azide, nitrides, it's azide. Okay, by heating azides, so sodium azide, what is its formula? NaN3, that is called sodium azide. Okay, if you heat this sodium azide, then you will get sodium plus dinitrogen. Okay, sodium plus dinitrogen. You can multiply 3 over here, 2 and 2 here. Okay, so this is one type of preparation. Again, another preparation also there. If you treat nitrous acid with urea. Okay, next, by treating urea with nitrous acid. Okay, nitrous acid formula HNO2. Okay, so urea, that will be NH2 CO NH2, then treated with HNO2, then it will give you N2 plus CO2 plus H2O, 2, 3 water, and here that will be 2HNO3. Okay, so these are the important methods of preparation, some methods of preparation of your dinitrogen. We will see some physical properties of dinitrogen. Okay, physical properties of dinitrogen. Physical properties of dinitrogen. Okay, first of all, it is a colorless, tasteless and odorless gas. It is a colorless, tasteless and odorless gas. Next, few points. It is lighter than air. Okay, it is non-poisonous in nature, still living matter living matter can't survive in its atmosphere due to lack of oxygen, okay. Next, it is slightly soluble in water. However, its solubility increases with increase in pressure, That's why sea divers generally used the mixture of oxygen and helium. Do you know why? Because whenever sea divers enters into the depth of water, then what happens? Generally pressure increases. So due to increase in pressure, the solubility of nitrogen in the blood also increases, the blood solubility of nitrogen, okay. So whenever they come back from the deep water, then what happens? The pressure gradually decreases and the dinitrogen, the solubility of dinitrogen also decreases. As a result, they try to come outside through bubble formation, okay. That's why sea divers feel pain at the joint regions, okay. So in order to prevent this, sea divers mostly used what? Mixture of oxygen and helium, because helium has low blood solubility, okay. Next, it can be adsorbed by charcoal, okay. So again, dinitrogen has high thermal and electrical conductivity, okay. Next, it neither burns nor helps in burning, okay. So these are few physical properties of your dinitrogen, okay. So next we will discuss about its chemical property. Next we will discuss the chemical properties of dinitrogen. Chemical properties of dinitrogen. Okay. So first one, that is nitrogen bonds in presence of oxygen to give nitric oxide, okay. And you know, before go through chemical property, this N2 is a stable molecule, and has high dissociation enthalpy, because nitrogen molecule, there exists a triple bond among two nitrogen atoms, so high bond enthalpy is required to break 3 bonds, okay. So regarding the chemical properties of dinitrogen, mostly reactions occur at high temperature. So mostly high temperature is required required for its chemical reactivity. For its chemical reactivity. Okay, so this concept should be kept in our mind. Now nitrogen bonds in presence of oxygen, and that is at high temperature to form nitric oxide NO. Okay, so reaction is that can be written as your dinitrogen combines with oxygen at high temperature to form nitric oxide. So reaction simple, N2 plus O2, and this reaction is reversible. Okay, so temperature is above 3000, that is 3273 Kelvin. You see, high temperature. Okay, so it will form 2NO, that is called nitric oxide. Okay, next dinitrogen combines with, that is industrial preparation, very important I am saying. Dinitrogen combines with dihydrogen to form ammonia, NH3 gas. Okay, to form ammonia gas. This is the industrial preparation of ammonia. Okay, this is the industrial methods of preparation of ammonia. Okay, this is called the Haber's process. Okay, so the reaction can be written as N2 plus 3H2. This reaction also equilibrium. Okay, and that will be occurs at 200 atm pressure and near about 700 Kelvin temperature. So you are getting 2NH3. This is called your ammonia. Okay, next dinitrogen combines with metals. Okay, let me vanish it first clearly so that it will be visible to all of you. Okay, dinitrogen combines with metals, active metals, like suppose this one is lithium plus N2. What will form? Lithium nitride. Okay, so that will be Li3N. Okay, so again temperature is required 723 Kelvin. Okay, so you just balance this 3 Li plus N2, that will be Li3N. You can 2 over here for N2, 6, and you can write over here 6. Okay, similarly lots of metals are there. For example, 3Mg plus N2. Okay, it will give you magnesium nitride, Mg3N2. Okay, similarly 2Al plus N2, it will give you what? Aln. Okay, so if you balance it, 2Al here 2. Okay, so these are interaction with active metals. If you consider calcium plus N2, then it will give you Ca3N2. All temperature is required, Ca3N2, calcium nitride, 3 over here. Okay, so this is reaction with metal. Okay, then dinitrogen combines with your calcium carbide. How? You see, dinitrogen plus CaC, this is called calcium carbide. Okay, then it will form calcium cyanamide, CaCN, calcium cyanamide, CaCN2 plus C. Okay, next Next here, it also treated with alumina like Al2O3 plus 3C plus N2 at 1273 Kelvin. It will give you 2Ln plus 3Cu. Okay, so these are some chemical properties. ठीक. Next, that is some uses of dinitrogen. Okay, uses of dinitrogen, it is used to provide inert atmosphere in certain metallurgical extraction process. Okay, and it is also used for filling electric bulbs. It is used in the manufacture of chemicals like nitric acid. Okay, during the formation of nitric acid. Okay, next, liquid nitrogen is used as a cryogen. Okay, dinitrogen gas is filled in thermometers also. Okay, so these are uses. Next, we will discuss very important compound from your examination point of view also, that is the first hydrides of this family. Which one? That is ammonia. Ammonia, formula NH3, it's called ammonia. Okay, so first let us discuss its preparation. So it can be prepared, ammonia can be prepared from ammonium salts. How? The reaction is NH4Cl, ammonium chloride, treated with sodium hydroxide, NaOH. Then tell me the product. NaCl, NH4OH, NH4Cl, that will be directly, it will form ammonia plus, okay, NaCl plus H2O. This is one method of preparation of ammonia. Okay, next, if you treat ammonium chloride plus calcium hydroxide, CaOH2, then it will give you, this is called slag lime. Then the product that is obtained, 2NH3 plus CaCl2 plus your 2H2O. So these are the method of preparation. Next, by heating nitrides with water also. Next preparation, by heating nitrides with water. So reaction can be written as aluminum nitride Aln plus, okay, 3H2 treated with water. Then it will form aluminum hydroxide, definitely LOH3 plus your ammonia, that is NH3. Okay, again if I consider magnesium nitride Mg3N2 plus, okay, 6H2 will gives you MgOH2 plus 2NH3. Okay, so this is also your another method of preparation of your ammonia. Okay, next, if you heat ammonium sulfate, that is very important method, one of the important method. If you heat ammonium sulfate, that is NH4 this is ammonium sulfate. If you heat this ammonium sulfate, then it will give you NH3 ammonia plus, okay, plus NH4HSO4, okay, plus NH4HSO4, ammonium hydrogen sulfate, This is also another method of preparation of ammonia. Again, a very good method is there, urea on treated with basic Urea also decomposed in presence of urease enzyme. The enzyme catalyzed, that is NH2CO NH2. This is your urea. Okay, plus water. The enzyme that is called urease. Urease. Enzyme is urease, giving rise to 2NH3, 2 ammonia plus carbon dioxide, CO2. Okay, so these are few methods of preparation of your ammonia. Okay, next we will discuss the very important how ammonia is prepared your industrial, that is industrial method of preparation of ammonia. Okay, industrial method of preparation of ammonia. Okay, manufacture of ammonia, that is called manufacture of ammonia by Haber's process, as per the name of scientist, that is manufacture of ammonia by Haber's process. Very simple what they have done. You see, suppose here they have consider this equation N2 plus 3H2. These two gases are required. Okay, 200 atm pressure, near about 600 Kelvin heat, and you are getting 2NH3 gas, and this reaction is your exothermic in nature. Okay, so experimentally how they prepared it in the your industry, that is here you can inject N2 gas in this tube, and there is another tube here you can inject hydrogen gas. So both the gas mixture are allowed to pass through a compressor. A compressor is here. Okay, this one is a compressor. So in this compressor what happens, two gases, that is dinitrogen and dihydrogen, get enter to the compressor. Okay, this one is called compressor, this one is your compressor to require a desired pressure. Okay, so here H2 plus N2, they begins to interact with themselves. Okay, here by applying pressure. So now what happens, this N2 and H2 are this region where your ammonia gas is created. So within this chamber what happens, this chamber contains ammonia, because formation of ammonia takes place within this chamber, formation of ammonia takes place. Okay, particularly at this chamber formation of ammonia takes place. So this is called ammonia converter. Okay, ammonia converter. So here it contains NH3, N2 and H2, because all the nitrogen and dihydrogens are not converted into ammonia completely within chamber. Okay, there are still free nitrogen and free hydrogen gases are also there. So now this gaseous mixture, okay, this gaseous mixture again allowed to pass the condensation chamber is there. So here you can do like this, and here in this chamber what happens, this chamber here water molecules are there, and the gas, this mixture get allowed to pass to this condensation chamber. Okay, so here what happens, this ammonia gas, hydrogen and nitrogen. Okay, so within this condenser, okay, this ammonia what get condensed to give you what liquid ammonia. Okay, here this ammonia get condensed into liquid ammonia. Liquid ammonia you can get over here. Okay, so after that the unreacted, the hydrogen, free hydrogen, nitrogen gas, hydrogen and nitrogen gas again subjected to recycling process. Recycling process, here again N2 plus H2, again recycling process, again you are getting ammonia. Okay, so this is your Haber's process. This is called manufacturing of ammonia industrially, or this is called your Haber's process. And in this process you can apply your Le-Chatelier's principle for better yield of what ammonia. Okay, you know this reaction is del H is negative, so that this is exothermic in nature. Exothermic in nature. Okay, so by according to Le-Chatelier's principle, for exothermic nature you can decrease the temperature. Decrease in temperature favors the liberation of ammonia. Okay, next pressure. If you increase the pressure that you have to increase for better interaction of nitrogen and hydrogen to get better yield of ammonia. Okay, so this is your industrial preparation, or this is called Haber's process for the synthesis of ammonia. Clear? Okay. Next, that is about its physical properties. Okay, physical properties of ammonia. Physical properties of ammonia. Okay, so this ammonia is particularly basic in nature, you know, because of presence of lone pair electrons, and it is highly, first important point, it is highly soluble in water. Highly soluble in water. Do you know what is the reason behind it? Because this ammonia molecule is a polar molecule. If you draw its structure NH3, okay, so nitrogen is more electronegative than hydrogen. So here if you consider this is delta minus and that is delta plus. Here this is delta plus, this is delta plus. So this is a polar molecule. Okay, and polars are dissolved in polar solvent. Okay, so this ammonia, if you interact with its polar solvent like water, then water also oxygen, hydrogen, hydrogen. Here we see this oxygen is a delta negative, hydrogen delta positive, delta positive. Okay, so what happens? This positive negative there is interaction, that is called your intermolecular hydrogen bonds. Intermolecular hydrogen bond. Due to such associative interaction, your ammonia is soluble in what? Water. Okay. Next we will go through regarding your physical property. You have to basically consider its solubility. Okay, why it is soluble in polar solvent? Because of its polar nature, it is soluble in polar solvent. Okay. Next we will discuss the chemical properties of ammonia. Okay, chemical properties of ammonia. Chemical properties of ammonia. Chemical properties of ammonia. So the first one, that is stability. Stability. First one, that is stability. Okay. So ammonia is highly stable molecule, you know. Okay, and it decomposes into corresponding constituting elements nitrogen and dihydrogen upon red heat. On strong heating, it is a stable molecule. It is a stable molecule and decomposes when subjected to strong heating, when subjected to strong heating, subjected to strong heating. Okay, so it can be represented like this: NH3 ammonia upon strong heating, that is red hot, you can say red hot. Okay, so it will give you N2 plus dinitrogen plus dihydrogen. Okay, N2 plus, you can see 3H2, so 6 hydrogens are there, you can multiply over 2 here. Okay, 2 NH3 giving rise to N2 and H2. Okay, clear. Next, combustion. Combustion, neither it burns or it helps in burning, but still it, on treated with oxygen, it gives dinitrogen and water. How? This 4NH3 plus 3O2 giving rise to your 2N2 plus 6H2O. So this is the reaction. Okay. Next, we will explain its basic nature. Very important. That is basic nature of ammonia. We will discuss its basic nature, and I have told you during my discussion of hydrates of this family, and I have told you their basic nature is due to presence of non-bonding electron pair over nitrogen, or you can say lone pair electron over nitrogen. So these hydrates of this family has tendency to donate ammonia. So let us consider in case of ammonia. Basic nature: NH3 is basic in nature. Basic in nature, that is due to the presence of lone pair electron over nitrogen atom. Okay, so it can, this lone pair electron, it can donate any deficient species, suppose proton, so leading to the formation of what? NH4 plus. Okay, so this ammonia act as a Lewis base, since it donates electron pair Lewis base. Okay, and this proton is your Lewis acid. Okay, this is regarding its basic nature. Okay, then if you treat ammonia NH3 plus any acid, let's say HCl, then it will give you your salt, that is NH4Cl, ammonium chloride. Okay, next we will discuss about very important chemical property, that is oxidation of ammonia. Okay, that is oxidation of ammonia. Oxidation of ammonia. Okay, oxidation means gain of oxygen. Okay, so there are few reactions. If you consider cuprous oxide plus treated with ammonia, okay, so this 2 ammonia, then it will give you 3Cu plus N2 plus H2O, 3H2O. Okay, if you treated like 3PbO plus 2NH3, then it will give you 3Pb plus N2 plus 3H2O. Okay, next there are two important reactions where you have to use. Okay, so addition of any electronegative element regarding the in oxidation process, that is reaction with chlorine. So chlorine is more electronegative in nature. Okay, so if it adds to nitrogen, then definitely that is your oxidation of ammonia there. So reaction with chlorine, if I consider NH3 plus Cl2 Okay, this is, it will form NCl3 plus HCl, NCl3 plus HCl. Okay, so here chlorine is present in excess amount, 3Cl2 and this will be 3HCl. Okay, that clear? Clear. Okay, next, if you treated ammonia to iodine, that will be 2NH3 plus 3I2, then an addition product is formed there, that will be NH3 dot Ni3 plus 3Hi. Okay, this iodine ammoniated nitrogen iodide is formed, explodes readily on drying. Okay, next we will discuss Ostwald's process, where the oxidation of ammonia is Ostwald's process in the manufacturing of nitric acid. So oxidation of ammonia is one of the major steps there. Okay, so oxidation of ammonia, that is NH3 plus, oxidation means combustion, it will give you your nitric oxide NO plus H2O. Okay, so that is 4, 5, 4, 6. Okay, so this method is applied in Ostwald's process. Ostwald's process during the manufacture of nitric acid HNO3. That clear? Clear. Next, reaction with Nessler's reagent. Okay, Nessler's reagent, a reddish brown pipette is formed. You see, Nessler's reagent 2Ki plus HgCl2. Okay, mercury chloride gives you Hgi plus 2KCl. How Nessler's reagent is formed over here, you see. So next, 2Ki plus Hgi2, you have to remember these equations, very important. Here this one is very important from examination point of view. Okay, 2Ki plus Hgi2 gives you K2Hgi4. K2Hgi4. This is called Nessler's reagent. Nessler's reagent, K2Hgi4. Okay, let us discuss its reaction with ammonia. Okay, next, alkaline solution of this Nessler's reagent. Alkaline solution of this Nessler's reagent, okay, it treated with ammonia. You see, the reaction can be written as 2K2Hgi4, okay, plus ammonia NH3 plus, since the medium is alkaline, so that will be 3KOH alkali medium giving rise to NH2 HGO, next that is NH2 HGO HGI. Okay, so this one brown PPT plus 7Ki, remember this equation, plus 2 water. This one is called iodide of Milan's base. This additional compound is called iodide of Milan's base, very important. Okay, next let us discuss about the uses of ammonia. Ammonia is pungent odor, ammonia having very pungent odor, you know, and it is present in various nitrogenous matter found in the living organism. Okay, ammonia, liquid ammonia is used as a very good solvent in your laboratory. Okay. Next, ammonia is used for the formation of ammonium compounds. Ammonia is used making artificial silk. It is used as a cleansing agent also. Okay. So now the final one, that is we have to discuss, forgot to discuss the structure of ammonia. Okay, I have forgotten it, but I think I have told it in my previous class. Okay, NH3, structure of NH3. The hybridization of nitrogen is sp3. Nitrogen is sp3 hybridized. sp3 hybridized. Okay. So the structure should be geometry. The geometry of molecule, that should be your tetrahedral. But I have told you, since it is having a lone pair electron over nitrogen atom, but due to lone pair bond pair repulsion, its shape becomes pyramidal. Okay, so normal bond angle should be say 109 degree 28 minute, but this is not in the case. In practical case, that will be 104 point something. Okay, so shape is pyramidal. This is nitrogen, lone pair, hydrogen. Okay, this is pyramidal geometry. Is that clear? So this is all about your group 15 elements. Okay, thank you.